right, getting right into division using boxes. I basically compiled this from a combination of what I've seen other teachers use, in addition to seeing what my students struggle with. When we talk about long division, one of the things my students struggle with is that whole process of divide, multiply, subtract, bring down. I found that using these boxes, in addition to having the students make a multiplication T-chart, actually does a very good job of assisting them with problems that involve long division. So in this first example, we have 552 divided by 8. 552, this 552, which is our divisor, is going to be put into boxes for each digit. So there's going to be 3 boxes for this particular total. A 5, and a 2. Now, how I use my 8 in this scenario is my T-chart. I'm going to make a T-chart that is counting by 8s. As we know, anything times 0 is equal to 0. Then we're going to use our 8 dots. 1, 2, 3, 4, 5, 6, 7, 8. Those 8 dots are going to help us keep count when we do get to counting. But first, I need to go from 1 on down on the left side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Some people stop at 9. I go to 10s just to make sure that it's counted correctly. And then from there, I'm going to use my dots to fill in this T-chart. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80. And I know this is true because 10 times 8 does equal 80. Now, what's different about this T-chart compared to the ones that we make when we multiply is the way that it's labeled. The left side is going to be labeled top of box. The right side is going to be labeled subtract. I'm just going to put a minus sign and then put inside. And I'm going to show you how that works for this particular box. What I'm doing in each box is basically seeing how close I can get to this actual amount on the right side of this table without going past it. Got to put blanks. You also have to put blanks above each box. So once you have blanks above each box, you can actually start the process. So I'm trying to see, for this first scenario, how close I can get to 5 on the right side of this table without going past it. As you can see from the table, the closest thing to 5 without going past is actually 0. That's why starting the table with 0 is important, because 0 is a possible digit that you can come up with in your answer. So 0 goes at the top of the box, and then I subtract 0 inside the box as well. So I see that 5 minus 0 is equal to 5. Whatever I have left over just goes on into the next box. So in the next box, I'm going to add the 5 to the 5 that's already there. Now I'm thinking, how how close can I get to 55 on this right side of the table without going past? Closest I can get to it without going past is 48. 56 would be too far. So 6 goes at the top of the box. And then subtracting inside, I'm going to subtract 48 inside. Okay, 5 minus 8 I can't do. I have to regroup. So that 5 is now a 4. One that I'm taking away is making this 5 a 15. 15 minus 8 is equal to 7. 4 minus 4 is 0. So again, whatever I have left, I'm going to take it over into the next box. So this 7 is going to make this now 72. How close can I get to 72 on the right side of the table without going past? Ooh, I can get exactly 72. So what this number pair tells me is that 9 goes at the top of the box. And then on the inside, I'm subtracting 72. 72 minus 72, equivalent to 0. So up here I have my final answer of 69. My quotient to 552 divided by 8 is 69. So again, doing this just for students that struggle with the whole division process in long division, this helps them tremendously. Okay, let's go on to our next example. Our next example gets even bigger. 3,809 divided by 9. So I'm going to do the same thing. This time I need a 4-digit box. So 3, 8, 0, 9. If you notice, not only am I putting it to the right, I'm also leaving some space above the digits in case I need to do any regrouping. Now I'm also going to make a T-chart. Counting by 9s. Now, just for time's sake, I am going to use a skip counting song by 9s that I use to help with multiplying. It goes 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, we're through. So that's to the beat of Take Me Out to the Ball Game. Just a quick way to get those 9s filled in. And our labels, the left side is going to say top of box. The right side is going to say subtract inside. Don't forget about your blanks above each box because there will be a digit here, even if it's 0. All right, let's get into this problem. Our first box. In our first box, we're looking at how close can we get to 3 without going past it using the right side. As you can see, the closest I can get is 0. So 0 goes on top of the box. 0 is also what I subtract inside. 3 minus 0 is 3. Since I have that left over, it goes on into the next box to make 38. So now I'm thinking about how close I can get to 38 without going past it using the right side. The closest I can get is 36. So I'm going to use that number pair for this box. 4 goes at the top of the box. 36 is what I subtract inside. 8 minus 6 is 2. 3 minus 3 is 0. So I'm going to bring that 2 over into the next box to create 20. And I'm going to be seeing how close I can get to 20 without going past it. Closest I can get is 18. So I'm going to use that number pair for this box. 2 goes at the top of the box. 18 is what we subtract inside the box. 0 minus 8 I can't do, so I have to regroup. That 2 becomes a 1. The 1 I borrow makes to 0, 8, 10. 10 minus 8 is 2. 1 minus 1 is 0. So I'm going to bring that 2 over into the last box. I need to see how close I can get to 29 without going past it. The closest I can get is 27. So I'm going to use that pair to help me with the last box. 3 goes at the top. And on the inside goes 27. So I'm subtracting 27. 9 minus 7 is 2. 2 minus 2 is 0. Now, as you can see, we have no more boxes, but we have 2 left over. This is now going to be our remainder. So yes, this method works. Two is our remainder. So yes, this method works even if there are remainders involved. I still have my quotient here of 423 and 2 as the remainder. So my final answer would be 423 remainder 2. In my last example, I just wanted to show that yes, even this method can work for 2-digit divisors. So we have 1,584 divided by 12. Now something I recommend when you're doing the bigger digits like this with 2 digits, like 12, I would use repeated addition to fill this in. 12. Another 12 would be 24. But you're definitely more than welcome to use the dots too. 36. 48. 60. Just for time's sake, we'll get that all filled in. Remember to label your sides of the table. Top of box. Subtract inside. Don't forget your blanks for each box. Okay, now I have to see how close can I get to 1 on this right side without going past it. That would be 0. So 0 goes at the top of the box. 0 also is subtracted inside. That gives me 1. Which makes the next box 15. How close can I get to 15 without going past? That's 12. So I'm going to use this pair. 1 at the top of the box. 12 is subtracted inside. 5 minus 2 is 3. 1 minus 1 is 0. Bring 3 over to make 38. How close can I get to 38 without going past? That would be 36. Which means 3 goes at the top of the box. 36 is subtracted inside. That leaves me 8 minus 6 is 2. 3 minus 3 is 0. Bring that 2 over to the last box to make 24. How close can I get to 24? How close can I get to 24 without going past it? I can get exactly 24. 2 goes at the top of the box. 24 is what I subtract inside. 24 minus 24 is 0. So that means I have no remainder. But I do have my quotient, which is right here above the boxes. 1,584 divided by 12 gives me a quotient of 132. Hope you guys enjoyed this method of dividing using the boxes. Let me know what you guys think in the comments. Take care.